morning, guys. Welcome. We're gonna be working on the Barron, the practice test number one, multiple choice. Right now, no calculator. I don't have a lot of time. Let's see how much we can get done. All right. So number one, here we have a piecewise function. We want to find the value of b where the function is continuous, and where the function is continuous, that means that you want the left hand limit to equal the right hand limit. So you're gonna go ahead. Let me zoom in a little more. We are gonna go and take the left hand side of the equation, but I'm also gonna plug in 1 because we want it to be continuous at 1. Then we're gonna go ahead and make it equal to the right hand side of the equation, and we are gonna go ahead and solve for b. E to the power of 0 is 1, which means this whole thing becomes 3 minus 2. And then we get that b is equal to 2. So there's our first answer. Number 2, h is a twice differentiable function. The table above gives selected values of h. Which of the following must be true? Okay, because the function is differentiable, that also implies that it's continuous. So h has no critical points. A critical point is when the derivative is equal to 0 or undefined. And if you look at the function, well, we start at negative 36, we go to negative 8, then we go to 4 and 24. This is just a rough sketch. I mean, there is no guarantee of h not having critical points, right? Like, even with a sketch already, I see a minimum. So, no. Oh, one of the questions got cut off. Oh, it's okay. I'm going to go ahead and jump to B. Let's see. H prime is equal to 10. Well, okay. No, let me go to C first. The graph H has no points of inflection. If I use the same sketch that I did for A, I mean, there's going to be a point where concavity switches, right? There's a counter example already. So is C going to be true? Not necessarily. D got cut off, but it says H prime of x is greater than 0 for all values of x, meaning the function is always increasing. Once again, looking at the example that I did, there's already a counter example right here. D is not going to be true. The answer is B. H prime of 10, H prime of x equals 10 for some value. That is correct, because if I take H of 2 minus H of negative 4, then we're going to get this is going to be 60. 60 over 6 is 10. And we were told that the function is differentiable. Therefore, by the mean value theorem, the instantaneous rate of change should equal 10 at some point. Number 3, we have x, we have y. We want to find dy dx. To find dy dx, you have to find the derivative of y with respect to t divided by the derivative of x with respect to t. The derivative of sine inverse is 1 over the square root of 1 minus x squared. The derivative, the derivative of x, let's do it separately. If x equals 1 minus t squared to the power of 1/2, its derivative is going to be 1 minus t squared to the power of negative 1/2, and then times the derivative of the inside, negative 2t. That derivative is this. Okay. Next, we can go ahead and multiply by the reciprocal. But we're not just going to multiply by the reciprocal. I'm also going to simplify these right here. And the radicals cancel each other out, leaving me with 1 over negative t. And number 4, if the series is a geometric series where all positive terms with B1 is 90 and B3 is 10, then figure out what happens with the series. Okay. Well, if the first term is 90 and we don't know the second term, but we know the third term, then we know we're going to have a common ratio, right? They did tell us it's geometric. So, in other words, if you start with 90 and you multiply that times r, you're going to get 10. So, let's figure out what r is. Take the square root. That's going to be plus or minus 1/3. Okay. But they did say the geometric series of all positive terms, which means r cannot be negative. If r is negative, we're going to have an alternating series. But we have a series with all positive terms. So there's my common ratio. It's 1/3. And because r is less than 1, well, the series is going to converge. Let's figure out. My first term is 90. So 90 divided by 2/3, it's going to be 90 times 3/2. That's going to be 45 times 3, which is 135. Okay. Number 5. The table gives us values of differentiable functions f and g. Find h prime of 3. Okay. H prime of x equals g prime of f of x times f prime of x by the chain rule. Therefore, h prime of 3 is g prime of f of 3 times f prime of 3. Reading the table, we can see that f of 3 is 4, and then f prime of 3 is 2. Now g prime of 4, that's 1/2, which means the answer is 1. The integral from 1 to 2 is equal to, all right, to get my antiderivative, I'm going to add 1 to the exponent and divide by the new exponent. But we also have we're going to have to do a chain rule, right, or a U substitution. The derivative of 3x minus 2 is 3. But because I'm doing an antiderivative, I'm going to multiply times the reciprocal of that. Okay, so this gives me 1 over 12. Evaluated from 1 to 2. And I'm going to take the 112 out. Just going to go ahead and work with the part of the function. So that's going to be 3 times 2 is 6. So 4 to the power of 4. 1 times 3 is 3. 4 to the power of 4. 16, 64, 256, which is 255. Okay. Maybe we can divide by 3 because the answer is not there. 3 goes into 25 8 times. 3 goes into 15 5 times. So 85 over 4. Ooh, sorry if I'm rushing, guys, but it's already 8:04, and I'm going to have to leave pretty soon. Okay, given the parametric equations x and y, which expression gives the length of the curve? Okay. Well, I know it's going to be the integral from 1 to 3 of the square root of x prime squared plus y prime squared. Dt, right? Yeah, dt. X prime is 40. And y prime, oh, they're trying to throw me off with that fraction right there. That's going to be 3t to the power of 1/2. And if I square, that's going to be 16t squared plus 9. Multiply the powers. 1/2 times 2 is 1, so just 9t. Is that my answer already? Yes, it is. What is the radius of convergence for the series? Okay. You guys need to get into a habit of showing the work, right? I forgot what word I was looking for, but don't skip the little things, right? Because this is the part that kind of made you guys miss some points in the FRQs. So if we're going to be doing the radius of convergence, we got to use the ratio test. So set it up, right? The limit as n approaches infinity. Okay, now we got to get our a of n plus 1. And then divided by a of n, or multiplied by the reciprocal. Set it up with the absolute value. Again, the setup gets you guys points on the FRQs. So make a habit of always showing proper work. Okay, so now let's go ahead and split up the powers. X minus 7 to the power of n times x minus 7 to the power of 1, 3 to the power of n times 3 to the power of 1. Then we have n plus 3 to the power of 4, and then everything else stays the same. Let's see what's going to cancel off. This guy with this guy. This with this. And technically, once I take the limit as n approaches infinity, technically this with this, leaving me with the absolute value of x minus 7 divided by 3 is less than 1. So that means that negative 1, you know what, let's multiply by 3 already. Negative 3 is less than x minus 7, which is less than 3. Add 7 to both sides, and we should have 4 and 10. The radius, well, if you think as 4 and 10 as the diameter of a circle, right, the radius is halfway, so the radius would be 3. Okay, one more question. Okay, which one has the slope field below? Well, I mean, I can already tell you that the answer is A, but let's see why it's not the other ones. 5 over x. When x is negative, we should have a negative slope field. And x is negative here. And as you can see, some of the slope fields are positive, so not it. For dy dx, let's pretend they're both negative, which means the slope field should be positive. Where are they both going to be negative? In the third quadrant. And you can see that my line segments have a negative slope. So that is not it. When y is greater than 0, the slope should be growing. But if you focus on even focus on these lines right here. As y increases, again, it's 5 times y, the slope should be increasing, and it's not. It's actually doing the opposite. It's decreasing. So it's not D. Our answer is A. You can verify it with any point on any quadrant, but that's what it is. You know what? Let's leave it on an even number. So let's do one more. Consider a function that is continuous on a closed interval. I mean, those conditions already scream intermediate value theorem to me, but let's go through it. H is increasing from 4 to 6. Well, just because you start at 5 and you end at 13, it doesn't mean you're always going to be increasing. Here's a counterexample. The derivative is 4, has at least one solution. They never said the function was differentiable, so you can't assume that it is. The value of h of 5 is somewhere in between 5 and 13. Well, no, we can use the same counterexample right here. Let's pretend that's h of 5. So no, h of 5 is not greater than 5, necessarily. H of 12 has at least one solution. By the intermediate value theorem, yes, it does. Because if you start at 5 and then you end at 13, at some point, no matter what, you're going to hit 12, right? 5, 13. Even if I do this, at some point, you must hit 12 at least once. So it's D. Okay, I'll stop right here because I got to go. But thank you very much, and I'll work on the next ones pretty soon.